Okay, in the last video, all I focused on was really big numbers written in scientific notation. So for this video, I'm just going to focus on really small numbers written in scientific notation. And I'm going to just show you on graph paper. And because the problems in the book are just a lot of vocabulary you don't need to know. So let's start with a really small number. When we talk about really small numbers, we're talking about things like the size of a cell or the size of a nuclei inside of a cell. So really small numbers sometimes don't fit in our calculators, so we need to abbreviate them using scientific notation. And just like really big numbers, I can change this to 8 times point 1, 2, let me count the zeros here. 1, 2, 3, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This, we don't count the zeros when we try to write it in scientific notation. We count the place values. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 place values. So this number in scientific notation is 10 to the negative 9. And just like with really big numbers, we don't have to do this middle step. We can just count how many places we're moving the decimal. And what we're really doing is repeated division. When this negative exponent means divide by 10 9 times, and we get this wee little number. So let me do another example with more digits. So remember, the goal in scientific notation is to have this number, the first number, always be between 1 and 10. Less than 10, equal to or greater than 1. So I need to move this decimal over here. So I count the place values, and it's 5, and I was moving it backwards, and it's a wee little number, so my new number is 2.3 times 10 to the negative 5th power. And again, the negative exponent just means divide by 10 5 times, and it gives us this number. I'll do one more, and then we'll do a couple of quick examples in the book, and then I'll teach you how to compare numbers written in scientific notation, and tomorrow I'll make a video for you on operations. All right, so let's go the other way. Say I have a number written in scientific notation, and I have to convert it to standard form. Standard form means just write it as a number. So 4.8 times 10 to the negative 9 means divide this number by 10 9 times. So I'm going to move this decimal 9 places. So that's one place. How many more places? 8 more places. So that's how many zeros I put out front. 1, 2, 3, 4, 5, 6, 7, 8, and then my 4, 8. And remember, the decimal was here. So if I check my count, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So in the book, I'm going to go to page 649. So on page 649, forget about all this nanometer, micrometer stuff. It's a lot of vocabulary that you really don't need to know. Let's just fill in this table. So when we're given the number in scientific notation, we're going to convert it to standard form, which means just write it as a number. And when it's written in standard form, we're going to write it in scientific. So if you notice this first one, the exponent is positive 6. So that means it's a big number. So we're going to move the decimal in a direction that creates a bigger number. I need to move it 6 places. So moving it from here takes up 2 places. So I add 4 zeros. 1, 2, 3, 4, and put my commas in. When it's written as a number. We're going to write it in scientific. So let's figure out where to put the decimal. 1, 2, 3, 4 places. So 7.71 times 10 to the fourth. And it's a positive 4 because it's a large number. So now we have an example with a small number. That means we know we're going to have a negative exponent. The decimal goes between the 4 and the 2 to have a number between 1 and 10. So I move this 1, 2, 3, 4. So it's 4.2 times 10 to the negative 4. And then the last one, oh my goodness, negative 16. So this is a really tiny number. And I have to move this back. Is that a 16 or a 15? Even I can't see. Oh, it's a 15. So I had to move it back 15 places. So that's one place. So I need 14 zeros because this takes up only one. 1, 2, 3, 4, 5, 6, 7, 8. 14 and then my 1, 6. Okay, so I said I was going to teach you how to compare numbers when they're written in scientific notation, and I think that's right on the next page. Yeah, it is. So when we compare numbers in scientific notation, we're going to look just at, first at the exponent. If the exponent is the same, which in this case it is, then you compare the two numbers. Which one's smaller? So the 1.5 is smaller, so my arrow points at my smaller number. The second one is the same way. Which the exponents are the same, you check that first, and then which is smaller, and we point at the smaller one. All right, so what happens when the exponents are different? When exponents are different and we're dealing with positive exponents, the smaller exponent is the smaller number. And if you wanted to, you could write them out. 4.5 times 10 to the fourth. Remember, I'm moving my decimal 4 places, is 4,500. And if it's to the seventh, 1, 2, 3. So you can always write out to check your work. So this is the smaller. When the exponents are not the same, it's really easy. Whatever the exponent's smaller, you point at that one. The 9 has the smaller exponent, so it's the smaller number. The 4 is the smaller exponent, so it's the smaller number. The numbers in the front don't even matter. All right, so let's go to the next page on page 651, and let's look at how this is different when there's negative exponents. So just like with positive exponents, when the exponents are the same, whichever number itself is smaller is the smaller one. So 1.5 is smaller than 4.5. Same thing here. The negative 12 is the same. So 7.6 is smaller than 8.1. Okay, so what happens when the exponents are not the same? So what you have to think about is which of these numbers is further away from 0? Because the one that's further from 0 is the smaller one. And I'm just going to show you by writing it out. This is a wee little number, so I had to move this direction. So this is 0.1, 2, 3, 4. So this one has 3 zeros, then my 4 is my other place value. This one is going to have 6 zeros, and then my number. So the smaller number, this is negative 7 is further from 0, or a smaller number than negative 4. So between negative 15 and negative 13, negative 15 is smaller. And if you think of it like temperature, it's colder, so it's smaller. Negative 9 or negative 12 is smaller. Negative 8 or negative 4, negative 8 is smaller. Okay, so that kind of wraps up the comparing and negative, dealing with negative exponents. A good practice page for what we just went over is 653 and 654. And I will send you a video tomorrow for doing operations and scientific notation. Okay, hope that helps. Send me an email if it doesn't work.